Wow. Okay, here we go. We're doing notes on chain rule. Notes are on the chain, but they might also be off the chain. I just thought of that. You're welcome. They're on the chain and off the chain at the same time. You love it though. You love it. No, it wasn't.
I don't know, I'm delirious right now.
So that you're saying that's why you laughed, was because you're delirious.
Literally.
Wow. Well, if y'all would like to know, I beat Donkey Kong Country this weekend. So.
Mario Kart?
Huh? No. The Donkey Kong video. Oh my gosh, you noobs. Come on.
Mario Kart.
Okay, I play Mario Kart so much I had to wait 13 hours until the new cupcake arrived.
Me too. Hey, you should.
Okay. Do you remember this guy?
No.
Yes, you do. Come on. You did it. Do you remember what it's called?
Product?
Not fog. No, it's a circle. The word's already on the screen.
Chain rule.
No.
Composition.
I was like, I know it's a C.
That's 3 words.
Yeah, well, it's called a composition. So a composition of functions is when you have F, little o, and then a G. It's not fog. Okay, that's F, composition G. What does that equal? Do you remember?
Is it?
F of
Oh, G of X inside.
F of G of X. So, chain rule is used when you have a function plugged inside another function. Okay?
Fog.
Yes. Okay, but we're going to call it a composition of functions. So, I'm going to make you a quick yes-no list so you know if you're using chain rule or not. Okay, so here's your chain rule side. Here's your not chain rule side. Okay, this would be on the chain and off the chain. Okay, if you were doing the sign of 2x, that would require chain rule because that's sign of and then 2x is inside. Now, I want you to underline the middle function. What is the inside function there? 2x. That's the middle. Now, what if it said this? Sine x times 2x. Is that a composition of functions? No, that's a what? Good. Needs product rule. Okay, sine is multiplied by 2x. Okay, another example, d dx. Let's say you have 3x cubed plus 5 inside an e. So it's e up to the 3x3 plus 5. That is a chain rule. Underline the inside function. What would you be underlining?
3x cubed plus 5.
Okay, that's the inside function.
I sound so wild.
Okay.
I'm so thrilled to be here.
See?
Oh, if Kaylin's not going to be in 6th period today.
She's not, why not?
I broke her window.
Yeah, I saw that she couldn't go.
Of her car? You bully?
Do you want to know why? Do you want to know exactly what happened?
The short version.
Okay. So, we were leaving to go to school, and so I usually leave Kaylin so she can put up the dog because I don't want to.
Kaylin?
And
Her sister.
so she runs to the front door. I smash her into the wall so I can get out to my car. I start my car. She leaves the front door open. My dog runs out. My dog's behind Kaylin's car. She's starting to pull out. I'm yelling at Kaylin, Sammy's behind your car. Like, don't pull out. And so I open the door. I'm like, what are you doing? Like, go put the dog up. And she goes, no, I'm going to get to school. And I go, like, she made me so mad. I slammed the door so hard that the window broke. Like, it's not broken.
Now, I'm just saying, if she had run over the dog, neither of y'all would have to put it away. So, as an animal hater, sorry to say it, maybe that would have been better.
Okay, I'm just like, wow. I'm above average.
Just kidding.
Like,
Just
I'm
kidding.
above average strength.
Run the dog over.
I'm not bringing my dog.
I do hate dogs, it's true. But I love that you love dogs. Okay?
But you really don't like dogs?
No, I mean, I'm fine with dogs, I just don't want one. I love dogs just over there, you know? You with your dog.
You observe.
Okay, now, look.
Miss Nixon's my new favorite.
Oh, that's a hard thing to take.
I wonder how many people
Okay, look at it.
you overheard for teacher appreciation.
I'll think that's a keep going.
Yeah.
Dirt.
Okay, now look at it. Okay, look at the last one. Why would I not need to use chain rule here? I don't even have to use product rule. What could I do instead? Distribute. Okay, this I could distribute and then use no rules. No product or quotient or chain. Okay, so if you can fix it, then do it. If I can times in an x to the half and avoid product altogether, I'd probably choose that versus product rule. Now, what is my inside function for this guy?
3x plus 7.
Okay, and the way that I would write that is 3x plus 7 to the 1/2. So that might make it more obvious. That would be your rewrite on that guy. Correct. Okay. Alright, so pizza party people, you're leaving. Don't worry though, I'll video the rest of notes so you can watch it in your free time later. Okay, ready?
Can we leave and come back?
Yeah.
What's the pizza party?
It's for, they donated the most money, their class did. Okay, so here is the chain rule.
I spent nothing, not actually.
Wow.
She's just wild. From what class?
Coach Neff's class 1.
What subject is that?
She's the swimming teacher. I don't know what class they have. Maybe health or something. Okay. It's college transitions? Wow. Okay, ready? So if you are taking the derivative of f of g, here's how it goes. This is a function inside another function. Okay, pay really close attention for the first few examples, or I'm going to have to explain it a million times. Yes? Question?
I recognize this from last year.
It might be similar, but you didn't know derivatives last year, so it can't be...
But you take the g of x and then multiply to the f, right?
Okay, close. You would take g of x and plug into f, but keep in mind we're now finding derivatives of that. So you're going to do f prime, your g of x in the middle is going to stay the same. But then you are going to multiply by the derivative of g prime behind it. Okay? Okay, so when you are taking the derivative of a function inside another function, you're going to take the derivative of the outside function, which in this case is f, but your g in the middle stays the same. Then you will multiply by the derivative of what was in the middle. Okay? Now we're going to do several examples. Okay, it might be weird the first two and then it'll be fine. Okay, so number 1, example number 1, we are going to take the derivative d dx of 3x plus 4 to the 7th power. So, that's my function. Here's how it goes. The inside function, I want you to underline it. What's the inside function?
3x plus 4.
That does not change at first. So I'm going to do power rule around that thing in the middle. So my 3x plus 4 stays the same. What is the derivative of something to the 7th power? I would take the 7, I would times it down to the front, and then what would my new power be?
6.
6. Then I'm going to multiply by the derivative of the middle at the end. So the derivative of the middle would just be a 3. Then, I'm not going to leave the 7 and the 3 separate, I'm going to just combine them. So 7 times 3 in the front, what do I get? 21. 3x plus 4 to the 6th. That would be your derivative. Make sense? Yes. Now, we're going to take the second derivative. Are you ready? Okay, let's do one more and see if it helps. So that's the first derivative. Now we're going to take the second derivative of 21, 3x plus 4 to the 6th. Okay, so first step, my middle crap stays the same. I'm going to take the 6, I'm going to times it down on the 21. What is my number in the front going to be? 126, yeah? Just do 6 times 2 would be 120, and then 1 times 6. So 126, what is the new power on 3x plus 4? It was to the 6, I take away 1, now it's to the 5. Then what do? Times by 3.
Oh, so you just multiply by the coefficient?
You're multiplying by the derivative of the middle, which does happen to be the coefficient here. But it's not necessarily always going to just be a coefficient. Okay, then from there, I'd combine 126 times 3, which I'm doing on the calculator since I don't know what it is, and it's 378. Thanks. Make sense? Okay, so that's number 1. Now, this we would call y prime. What would I call this one? Y prime prime or y double prime, yeah?
Or y, what's this called? Quotation marks.
Oh, yeah. Y quotation, great. Okay, can I turn the page? Are we good?
Yeah.
We will do many more.
I don't like that.
This morning started out rough, but I think I'm in a better mood.
Good. I love that.
Can't relate.
Okay, next one, number 2.
Change my intern class.
Okay, y equals, let's do 6x squared plus 3 to the 4th power. Okay, ready? Now, that is y. The derivative I'm going to call y prime. Okay, the first thing that you do is the middle stays the same. My 6x squared plus 3 will not change. It will stay a 6x squared plus 3. But then I'm going to take the derivative around that core. So my 4 is going to come down to the front. What's the new power if it used to be to the 4th? Now it's to the 3. Then I'm going to multiply by the derivative of the middle, which is 6x squared plus 3. What will the derivative of that be?
12.
So times by a 12x at the end. Hello? She actually just got pulled for a pizza party with Coach Neff. Hey, do any of y'all have Chastity's number? Her phone number?
Which session?
You have her on Snap? I have a kid that can snap her. Okay, alright, I'll have him snap her. Thanks. Okay. Will you Snapchat her and tell her that her dad's here to pick her up? Okay, so what did we say we're timesing by at the back? Okay, the derivative is just a 12x. Good? Okay, now, would I leave these guys separate? No, why would I do that? I'm not going to do that. I'm going to times them together. So 4 times 12x is going to combine to a what? 48x, 6x squared plus 3 cubed. Now, if I wanted to take the derivative of that again, what rule would I need now that I'm taking the derivative a second time? What would that need? It would need chain rule and another rule you already know. Products. You might say it'll be a product of 2 different rules. Okay, this would now need chain rule and product rule. Now, I'm not going to make you do that one, but we are going to do that type of problem tomorrow.
So you are eventually
Okay?
gonna make a
Yes, eventually you'll have to do it for y double prime. Okay, but like I said, we're not doing that today, but you should notice that now I have two separate functions times together. I would need product rule at that point. Okay, number 3. We are going to take the derivative of the function y equals the cubic root of 7x plus 3. Now, in order for me to take the derivative, I need to rewrite that. How will I rewrite that as a power?
yx plus 3 to the 1/3.
Okay, so 7x plus 3 to the power of 1/3. Okay, remember, you want it to start off as a power so that you can take the derivative. So the derivative we're going to call y prime. Remember that initially, this crap in the middle does not change. If it was a 7x plus 3, it is still a 7x plus 3. But I'm going to take the derivative around that core. So my 1/3 is going to times down to the front, just like regular power rule. And then when I take away, I'm taking away 1, which is like a 3/3. What is 1/3 minus 3/3? Negative 2/3. Then I need to times by the derivative of the core. What's the derivative of the core?
7.
Combine the 1/3 and the 7. We're not going to leave those separate. What would we have then? 7 times a third is 7/3. 7x plus 3 to the negative 2/3. Now, if it was multiple choice, they would not leave it like that. 2/3 is the same as a squared and a cubic root, but it should belong where? On the bottom. So I'm going to put 7 on top. I'm going to put 3 on the bottom, and then my 7x plus 3 is going to be squared and cubic rooted. Does that make sense? So this would be like your multiple choice answer if they were going to try to make you have to match it. Okay, but this is technically already right. Okay? Now we're going to take the second derivative.
What? We've already got that one.
Okay, so this is the first derivative. Now we're going to take the second derivative. So what would I do first? My 7x plus 3 stays the same. That's the core of the problem. It does not change. But I'm going to take my negative 2/3. I'm going to multiply it down on the 7/3. Now remember, fractions, you just times the tops times the bottoms. So if it's a 7 times a negative 2, what's the top now?
Negative 14.
Negative 14, and then 3 times 3 is a 9. Then I need to minus another 3/3. It was already a minus 2/3. Minus 3 more thirds would be negative 5/3 times the derivative of the middle. What's the derivative of the middle there? 7. Now, nobody's going to leave that 14 and the 7 separated. So I'm going to multiply those together. 7 times 14 is?
Good question.
Great question. 7 times 14 equals 98. So negative 98 over 9, 7x plus 3 to the negative 5/3. Or, how could I rewrite that? They're not going to leave it like that.
Good.
You'd have your 98 on the top, and then on the bottom you'd have your 9, and then your 7x plus 3 is to the 5th power and cubic rooted. Get the idea? Not too complicated.
Salt that it would be.
You don't even have to do that, though.
Well, I have to, and I feel bad for them.
Okay? Good?
Sure.
Great. All
We
right.
like the example of this.
Next example. I cannot.
Example.
What am
I don't want to blow your minds with all the times you'll use this. Many times that you would use it. Okay, can I turn? Good?
So many.
My brain hurts.
So many. You'll be overwhelmed with how many times You might have to use this. Okay, so ready? Now, I'm going to give you chain rule versions of all your specials. Okay, they're easy. They're going to get easier now. Okay, so if you were taking the derivative d dx of sine u. Now, let's say for all of these examples that your u is going to be an expression with an x in it. So maybe it's like 2x plus 4 or 3x squared, but it's just x stuff, okay? What you're going to do is, what's the derivative of sine usually? Cosine u, and then I'm going to multiply by the derivative of u. We're going to call it u prime. Okay, now let's do it for cosine. d dx cosine u. Okay, remember, u is just a function with an x in it. What would I do? I'd take the derivative of cosine, what is it? Negative sine, and remember, my core stays the same. My u is still the middle. But then I'm going to multiply by the derivative of the middle, which is called what? U prime. Okay, one more like that. Last one we're going to do on this page is going to be the derivative of tan u. Okay, what's the derivative of tan usually? Secant squared. My core stays the same. But then I'm going to multiply by the derivative of u, which is called u prime. So far, so good? Okay, so first one we're going to do is going to be the derivative. What number are we on for? Okay, derivative d dx of sine 6x squared plus 5x. Me too.
I would be lost if I had to learn this on my own.
Okay, underline the core. What's the center function?
6x squared plus 5.
Okay, 6x squared plus 5x. Now remember, when I do the derivative, I don't change that at first. So if it's a sine on the outside, what do we say the derivative of sine is? So it'll be cosine of the core, 6x squared plus 5x. But then I need to multiply by the derivative of the core. What would the derivative of the middle be? Plus 5. Now, I have a PEMDAS problem. How do I fix it? Parentheses. Okay, that would be your answer. Now, usually on the AP test, they'll put your u prime first if it's something like that. So they'd probably do 12x plus 5 first, and then cosine 6x squared. Bless you.
Bless you.
There's some on my desk. Okay, next one, good? Okay, we're going to take the derivative now, d dx of, we'll do cosine 3x to the 4th. Okay, underline the core. Remember, the core does not change at first. What's the core? 3x to the 4th. So when I take the derivative, I'm doing it around that. So what's the derivative of cosine? Negative sine, middle stays the same. But then I need to multiply by the derivative of the middle. What's the derivative of the middle?
12x cubed.
Good. Now remember, typically for free response, that'd be fine. But multiple choice, they're going to pull that linear or cubic or whatever power in the front. So it'd be negative 12x to the 3, and then your sine 3x to the 4. Now, let's say you wanted to take the second derivative of that. What rule would you also need at that point? Product, because you have this times this. So d squared y dx squared would need product rule and chain rule. Okay? Alright, one more like that. We're going to do an example with tangent. So we're going to take d dx, tangent, we'll do 6x minus 9. Okay, take a look at it. Underline the core. Remember, that does not change. So if my function has a tangent in it, okay, 6x minus 9 is the core. What's the derivative of tangent?
Secant squared.
Okay, secant squared, and my core stays the same. But then I need to multiply by the derivative of the core. What's the derivative of the core? Times 6. But they're not going to put it there. They're going to put it in the front. So it'd be 6 secant squared 6x minus 9. Make sense? Okay, now I'm going to give you a product and a trig together. Okay? Don't act like I invented this stuff. Okay, I did it.
We need to find whoever did it
And go back in time.
Y'all know the TikTok where it's like, that should be me? No, that should be me, whoever invented that.
Okay, write it down. Now, remember I told you guys yesterday, or Friday I guess, okay, that when you have the number tucked in like that, that is the same as the derivative of sine 2x, and then all of that to the fifth. Actually, cross out the 2 just to make it easier. Just to make it easier, since you guys don't seem to like this as much. Okay, what do you do first? I just cut the 2 out of the problem to make it easier. Okay, so underline your core. What's the core? Sine x. So when I take the derivative, the 5 is going to move down to the front. So I'm going to have the 5 come down to the front. What is the new power now on sine x? Sine x is now to the 4th times, what's the derivative of the core if the core is a sine x times a cosine x? Now, how might I rewrite that? 5 cosine x, sine x with the 4 tucked in. That's how they would write it. Okay? But keep in mind that this is already right. It's just written a little bit differently. Okay, I only have 2 more examples for you, and then we'll look at your homework for a little bit.
Yay, the brain hurts.
Okay, your last 2 special rules. You know power rule, sine, cosine, tangent. What are the other 2? Okay, now avoid the easy ones. Easy. E to the x and natural log x. Okay, so derivative, your other 2 specials, e to the u. What's the derivative of e to the u usually? E to the u, but then now I'm going to times by u prime. Okay, then what's the regular derivative of ln u? Normally it's 1 over x, now it's 1 over u. And then what am I going to multiply at the back? U prime. So 1 over u times u prime. Here we go. Our function is going to be e to the 3x squared plus 7x. We want to take the derivative. What might we call the derivative if it's originally a y? Okay, I'm going to use dy dx this time just so you have both of them in your notes, but you can use y prime if you like it better. Okay, remember, derivative of e to the u. Underline the core. This is the core. So when I take the derivative of e to the u, it's e to the u again. So e to the 3x squared plus 7x times, and then I need to multiply by u prime, which would be the derivative of that exponent. What is the derivative of that exponent? 6x plus 7. Then we have a PEMDAS problem. What do we need to fix? Parentheses. Remember, you want to make sure if you're timesing only by 6x without parentheses is fine, but if you're multiplying by 6x plus 7, you got to group it. Okay, and then remember on the AP test, they would pull the 6x plus 7 to the front and let e come second. So basically anything complicated, they're going to put the easy stuff first. Okay, 1 more left, then we'll look at your homework. What number am I on? 9. d dx of ln of 3x plus 4. Underline the core. Core is your u. What is u in this case?
3x plus 4.
3x plus 4. Okay, so when I take the derivative, look back up at your rule here. Derivative of ln u is 1 over u times u prime. So when I take the derivative of ln 3x plus 4, what's it going to be? 1 over 3x plus 4 times the derivative of 3x plus 4, which is what? 3. Now, are they going to leave the 1 and the times 3 on the top separate? No, they'll put them together. So I would rewrite that as 3 over 3x plus 4. That's how they would write your answer. Okay? Now, we're going to take the second and third derivatives. So, second derivative would be called this guy. D squared y dx squared. And in order for me to take the derivative of this, you could use quotient rule. But what would be easier is to do a rewrite. If this is on the bottom, what could I use as an exponent to bring it to the top? -1. Very good. So I'm going to rewrite this as 3x plus 4 to the minus 1. So I'm going to pull the 3x plus 4 up, and I'm just going to turn it into a -1 exponent. Okay, here we go. Derivative. -1 times 3. What do I have in the front? My core stays the same, 3x plus 4, but instead of being to the minus 1, I have to take away 1 more. Now it's to the minus 2. Very good. Then I have to times by the derivative of the middle, which is a times 3. Now, are they going to leave those 3 separate? No, put it together. -3 times 3 is a -9. 3x plus 4 was to the minus 2. What other thing would they change if it was multiple choice? They'd put it back on the bottom and take the -2 and just make it a regular squared. So you'd have -9 on top, and then you'd have 3x plus 4 regular squared. Now, when I go to take the third derivative, which of these would I want to use? First or second? First. This is already rewritten for me. So when I take the derivative again, that'd be d cubed y dx cubed. Okay, you try it first. You're taking the derivative of this. Your core should stay the same. Take the derivative around it. So -2 up top times -9 on bottom. What's my coefficient now? 18. 3x plus 4 stays the same, but its power changes to a what? -3. Then I have to multiply by the derivative of the middle. Another times 3. So then I'd have for my final answer 54 over 3x plus 4 to the 3. But notice that it would be on the bottom because it has a -3 as the exponent. That needs to be in the denominator. Make sense? Okay, so get out your homework that you picked up today. And let me get you to try a few. Let's do number 1, number 3, and number 5. 1, 3, 5. Do not do number 6 tonight. You need the notes for tomorrow to do that one. It's a double. So 1, 3, 5. Let's see if you can get them right. One, 3, 5. Just one of each. See if we get them. Don't forget your power. Perfect. So good. Yeah. The squared still. 135. Just on the left side. Yep, that's right. Woo, high five. Booyah. Good, that's right. And then what do you multiply after? Yep, and then combine the 3 and 2. Good, that's right. Just 135. And then times by the derivative of the middle would be what, Dana? What would your derivative of the inside
So
be?
the next one would be cosine.
Just what you underlined. Derivative of that is what? Just the derivative of the middle. So it's 2x minus 7. The derivative is just and then 3 times 2, combine those in the front to be well, no, that's the answer then. So you'd have a 6 in the front, because 3 times 2 is 6, and then keep the 2x minus 7 squared. That's your answer, then you're done.
This way.
Yep, good job.
So multiply
Yep.
by, what, 29x to the 4th plus 2.
You said 135?
Yeah, just to see if you got the idea. So number 1 should have been 3 times 2x minus 7 to the what? Squared times 2. Then 3 times 2 is 6, 2x minus 7 squared. Got it?
Do we have to multiply that 3 out?
Yeah. Okay, then 3 is probably the last one that you're going to really have time for. Well, I guess we're not that bad on time. Okay, derivative of sine, what is it? Cosine. The middle crap stays the same. 4x5. Oh, wait, never mind. Bye. We'll do it next time. Good job.
She's like, oh, you have plenty of time. Then they say no.
I think it's 9 o'clock, right? Or is it 9? I need to fix my clock. Dang it. Yeah. Yeah, you have to come in to take it though. When can you do it? Can you stay Tuesday or Thursday? When Tuesday, Wednesday, or Thursday?
Yeah.
Okay. Huh? Test corrections, you mean?
Yeah.
Okay, let's get them done. When can you do it? Tuesday, Wednesday, or Thursday after school? Yeah,
Jeremy gets
What is like due to register the name test?
Friday.
This Friday?
Yeah, but you don't have to have paid by Friday. You just have to have registered on total registration and on College Board. Did you do that when we did it in class?
I guess my email was.
Okay, but you got it working now? Okay, by Friday.
Wednesday? Can we come Wednesday?
Wednesday after school, yep.